In the present video, we're going to talk about the use of units when defining matrices or vectors of data, as well as the application in graphics. For that purpose, we're going to start with this SMA Studio file, where I have defined a vector called masses to enter a particular element. Is as simple as typing, for example, here 1.4 apostrophe slug slug. In this vector, all the units have the same dimension, masses. And so if I type, but to produce this result, all you have to do is type masses equal, and it gives you the conversion, automatic conversion of all the elements to the units, the basic units of the international system, which is kilograms. And that's what you get. Now, if you wanted to produce a result like this, what you have to do is click on the right-hand side of your last result, where you have kilograms, and type apostrophe kg right here, and then you get this result. Actually, you could have done it right here. Well, no, you actually have to make a masses equal to produce the change of units. So we've done that, and that was the result that we started with, and this is what we ended up with. Now, in this case, I have a vector where I have different dimensions. These are dimensions or units of mass. These are units of force, mass again, and force. So when you do that and you make it equal to, you get the units of the basic units of the international system: mass, kilograms, force, kilograms times meter per second square, which is Newton, but they prefer to give you the most basic units. And so this is what we're getting for these four results. There's no way to produce a common unit for this because they belong to different dimensions. But if you click here and you type apostrophe kg, then you're going to get this result where every element in the vector has been divided by kilograms, giving you the remaining units. Right. So what I've done here is repeat the V equal and extract as common unit the Newton, for example, the kilogram here, the Newton here, slug, and pound force, and you get different numbers because the remaining units here have been divided by different summarizing units, I would say. Let's see, if all of the elements have the same dimensions, like here would all have dimensions of forces: Newton, pound force, dynes, and ton force. Of course, when you make equal to, you get the basic units of the English system. But you could extract as a common unit one of the particular units of forces, like newtons in this case, or dynes in this case, and you get vectors of numbers without any unit attached to it, except for the one that's outside. In the following example, I'm using a matrix. This matrix has 3 by 2 elements, 3 rows and 2 columns, where all the units are units of pressure. So when I make the equal sign, I get the basic unit of pressure on the international system is the Pascal, which is a Newton per meter square. But the Newton is kilogram times meter per second square. And so when you simplify things, you end up with kilograms per meter times second square. If you take a common factor like Pascal, for example, you get your matrix of absolute values all multiplying Pascals. We could change this to, I don't know, for example, bar, which is another unit of pressure, and this will be the result. If you want another format to present data where all the elements belong to the same dimensions, will be to divide the name of the vector or matrix by an appropriate unit, like pound force in this case, or bar in this case, to provide only the absolute values to the right-hand side. We're going to be using that with graphics. And here we divided by pound force. We could have divided by Newton. I'll give you a different value. And here we could have divided by atmospheres, and it will give me different results. All right. So this is regarding the use of units in vectors and matrices.